Introduction of Differentiation. Question 1. Explain the meaning of differentiation in mathematics and in three techniques of differentiation. Differentiation is the fundamental concept in calculus dealing with the rate at which the quantity changes. It is a process of finding the derivative of a function, which provides information about the slope of the function at any given point. Next is technique of differentiation. First is power rules. It used to differentiate the power of x. Second, we have quotient rules. It applies when one function is divided by another. The last one is product rules. It applies when two functions are multiplied.
Hi, my name is Alina Luzin Alisha, and I will answer the question number 2. The question asks to differentiate the following function with respect to x. We have two questions, A and B. For question A, the question is y equals to 5x power of 3 exponent cos x. So by the question we know we need to use product rule. We assume 5x power of 3 as u and exponent cos x as v. So now we need to find the u prime and the v prime. So how to get the u prime? We need to differentiate 5x power of 3. We got 15x power of 2 because we multiply 2 with 3, the power, we got 15. And then the power n minus 1, we got 3 minus 1, we got 2. And then for the v, we need to differentiate the exponent cos x. Exponent cos x, we differentiate, we still got exponent cos x. But we need to differentiate the angle to cos x. We got negative sin x. And then we need to multiply the u prime with v and the u with v prime. And then we got this. So we need to simplify the equation we got. And then we factorize 5x power of 2 exponent cos x. And then the other, we need to put it in bracket like this. And that's the answer for A. Okay, for the next question, B, the function given are ln 5x over sin 2x. So by the logarithm formula, we know that if we got log A per log B, it will become log A minus log B. So we use the same formula here. So it will become ln 5x minus ln sin 2x, like this. And then we differentiate one by one. So we differentiate ln 5x first. For ln, it will become 1 over the function. So we got 1 over 5x. And then we differentiate 5x, we will get 5. And then minus, put minus here. So ln sin 2x, we differentiate ln sin 2x, we got 1 over sin 2x. And then we differentiate the angle sin 2x, it will become 2 cos 2x. And then we simplify one by one, where the first one, ln 5x, will become 1 over x. And then this one, it will become 2 cos 2x over sin x. And we know that cos over sin, it will become cot. So we just write it back here, 2 cot 2x. Because cos over sin or cot. So that's the answer. That's the final answer. 1 over x minus 2 cot 2x. That's all for question number 2. Thank you.
So for the question 3, given y sin 2x minus ln 2y equals to 2x squared plus 3, find dy dx using implicit differentiation. So here we have y sin 2x, which is it has two factors that multiply together, which is y and sin 2x. So we have to use the product rule. V u prime plus u v prime. So let u equals to y and u prime equals to dy dx. And for v sin 2x and v primes equal to 2 cos 2x. And for ln 2y, we have to differentiate it using formula of derivative, which is ln fx equals to 1 over fx times f prime x. So here we get 1 over 2y times 2 dy dx. So we can cancel 2 and it will become 1 over y dy dx. And for the right side, on the right side, 2x squared plus 3, we differentiate it and it will become 4x. Okay, then we combine it together, which is vu prime, so sin 2x dy dx plus uv prime, like this, uv prime y 2 cos 2x minus, don't forget here, minus 1 over y dy dx equals to 4x on the right side. Okay, and then we collect all the dy dx term together, so it will become like this, sin 2x dy dx minus 1 over y dy dx equals to 4x minus this plus become minus here, and then this you have to factorize on the bracket, so it will become 2y cos 2x, and then you have to factorize the dy dx, so it will become like this, dy dx sin 2x minus 1 over y equals to 4x minus 2y cos 2x, and then make the dy dx as the subject, so dy dx equals to 4x minus 2y cos 2x over sin 2x minus 1 over y. So this is the answer. That's all. Thank you. Bye.
So for question 4, use linear approximation to estimate the value of 15.98 square root of 4 minus 2 square root of 15.98. So first we need to find the x1. x1 is the number that given in x that have number in decimal places. So we took 15.98. So for x note, we get from two number 15 and 16. Square root of 15.98 and square root of 16. So which one we get the whole number? That is the one that we choose as x note. So it is 16. And then we find fx. Fx is from this. Substitute 15.98 as x. So x, the power of 1 over 4 minus 2x, power of negative 1 over 2. And then we differentiate the fx. So it is called f prime x. So 1 over 4x, power of negative 3 over 4, plus x, power of negative 3 over 2. So we move on to the next part, which is we use this formula, fx approximate fx naught plus f prime x naught times delta x. So we just substitute this value to this formula. So fx approximate 16 power of 1 over 4 minus 2 times 16 power of negative 1 over 2, and don't forget to make your bracket, and then plus open bracket 1 over 4 times 16 power of negative 3 over 4 plus 16 power of negative 3 over 2, and close bracket, and then open bracket for delta x. x1 minus x naught. So x1 is 15.98 minus 16, and then calculate it with your calculator, and we should get the answer approximate 1.499, and we get the answer in 3 decimal places, and we are done.
In conclusion, differentiation is important in calculus as it measures how a quantity changes at a specific moment and identifies points where the derivative is zero, which often relate to a maximum or minimum values, turning points, and other key features of functions. That's all. Thank you.